Hey guys, we are going to talk about system word problems, which is just word problems like last time, but for systems. So the first thing you need to know is defining the variables. So to define a variable, that means explain what each letter represents, and it should be numeric. You don't want it representing an object, you want it representing a number. And my hint on what to make the variables is to look at what they ask you to find, because if they ask you to find it, that means it's unknown. So you might as well make it a variable. Then we have some steps to solve. So the first step is to define the variables you will use. Because we have more than one, we need to tell the person who's reading it, hey, these are what these mean. Then you make or write a system of equations based on the problem. So that's going to be 2 in this case. Then it says determine which method you want to use and solve it, which we'll go to how to know in a second. And then once you've done that solution, you want to use it to answer the question. So they'll ask you a question and you'll answer it as opposed to just saying, hey, this coordinate point is the answer. Now, how do you know which method to use? Because we know 3. So there's some hints I'm going to give you. The first one is to graph, you do this when both equations are in slope-intercept form because that's easy for graphing. Then, for substitution, the first step is to make sure one of your equations is either x equals or y equals. So when one of your equations is already x equals or y equals, that's good for substitution. And lastly, elimination is great when both equations are already in standard form, because then you can just go straight into solving. So we'll do one example of each below. The first one says, 2 birds are flying in the air. Bird A starts at 500 feet in the air and is descending at a constant rate of 75 feet per minute. Bird B starts at 100 feet in the air and is ascending at a constant rate of 25 feet per minute. How long until the birds are at the same height in the air, and what is that height? So those questions are going to help me determine what my variables are. So the first question is, how long? So they don't know what time those birds will be at the same height. And since they tell us it's feet per minute, we're going to want to do measurements in minutes. So M is going to represent minutes past, since I started watching these birds, I guess, if I'm a bird watcher. How many minutes have passed? Then the second thing that asks us, well, what is that height? So I don't know when they cross paths, what is that height in the air? So I'm going to call that h, and that is our height from the ground. Okay. Now, you can already tell I'm going to do graphing because I provided you with a graph, but here is how you can know by reading the thing, is that it tells us bird A starts at 500 feet. That's a starting point, or your y-intercept. And then here it says, then it is descending at a constant rate of 75 feet per minute. Well, a rate is slope. Then we have slope-intercept form. Whoopsie, sorry. So that means bird A, its height is equal to, starting at 500 feet, and then since it's descending, that's subtraction. So we'll minus 75 feet per minute. And there's the equation. So same for bird B. Bird B starts at 100 feet in the air and is ascending, which is up, so I'm going to write plus next to it, at a rate of 25 feet per minute. So what that means is bird B has a height equal to starting at 100 and then plus 25 feet per minute. And I know what you're thinking, well, Ms. Azor, that doesn't really look like slope-intercept form. Well, actually, if you replace this h with y equals 500 minus and then 75x instead of m, now I do have slope-intercept form. So the difference is that the slope is always with x, so the slope is second, and that's fine. We start at 500, and you can see each of these tick marks is 25. So I go down 25, 50, 75 over 1 minute, then down 25, 50, 75 over 1 minute. And I keep doing that. And then I use a ruler in real life, which is me right now. And you guys will use the line tool because you need those to be straight so that you get the real intersection and not the wrong answer. So that's the flight of my first bird. And then I can do the same thing for the second bird. Again, I'm going to replace the h with a y equals 100 plus 25, and then instead of m, I'm going to put x. So again, this is like slope-intercept form, but the slope comes second, and that's okay. Just make sure that you don't get those mixed up. It's not whichever comes first, it's whichever one goes with the x is the slope. So now I start at 100, and again, each line is 25. So up 25 over 1, up 25 over 1. And I do that, and then again, I take my ruler, and I draw my line. So the solution when you graph, remember, is their point of intersection. So in this case, that's right there, and I go down to the x-axis, and I can see that that should be a 4, and that says time passed, and if I come over to the y-axis, that's right at 200. So again, the answer is not a coordinate point. We need to answer the question, how long until the birds are at the same height? What is that height? So how long is 4 minutes? So after 4 minutes, both, because the birds are in the same place, birds are at, and then the height is 200 feet. And now I've answered the question. So I use that solution to answer the question. Okay. Now, the next one I call mystery numbers because there isn't really a context. It's just asking us to find some numbers. It says the sum of two numbers is 92. The first number is 4 less than 11 times the second number. Find those numbers. So that's the question. Those are my unknown. And you can tell there's two because it says two numbers and then first number, second number. So what I'm going to do is you can pick any variables you want. I'm just going to make x be the first number and y be the second number because it refers to them as first and second over there. Okay, so now this first sentence tells me that the sum of the two numbers is 92. Well, sum means addition, okay? So they tell me that if you add those two numbers, it is or equals 92. So that means that we have x plus y equals 92. Okay, and then we can diagram this second sentence, just like we did last semester. So first number, I called that x. Is means equals. 4, less is minus, than means flip, 11 times, and then the second number I called y. So remember when it says flip, you flip it around the operation, which is minus, not around the equals. So you start with x equals, and then instead of 4 minus 11y, I have 11y minus 4. Okay. Great, so notice that this falls under the second category. You have one of my equations is x equals or y equals. In this case, it happens to be x equals. So I can take this, and remember my weird sleeping bag analogy, you can put it in for x. So all this is going to go in that spot. So there won't be any x anymore. So instead of x, I'm going to write what's in my circle. 11y minus 4. Now I'm done, you continue on with this equation. Plus y equals 92. And now I want to solve that. So when we look at this, we want to put a y in front of, or a 1 in front of that y, because I have 11y plus 1 more y, that's 12y, minus 4 equals 92. And now it's just a two-step equation. I'm going to add 4 to both sides, so that those 4's are gone. 12y equals 96. And then divide both sides by 12. Y equals, and I did use a calculator earlier, it's 8. Okay, so now I know y equals 8. So to find the second number, or x, I'm going to take this 8 and put it in for either equation, but I'm just going to put it in here for this y. So I have x equals 11, and instead of y, it replaces the y, guys, that's gone. times 8 minus 4. And again, you could use a calculator for this. 11 times 8 is 88, minus 4 is 84. And there is your two numbers. So you could say the first number is 84 and the second number is 8, or I'm just going to say that the numbers are 84 and 8. They didn't ask which is the first and which is the second, but you could tell them if you wanted to. Just make sure you tell them the right one. All right. Now, the last one, in my opinion, is the most difficult. Obviously, it's why we save it for last. It says that the homecoming dance at Lincoln High School happened last Saturday. Many students purchased tickets in advance for $6. Other students bought tickets for $7.50 at the door. Ticket sales totaled $1,905, and 290 students attended the dance. How many students bought tickets in advance, and how many at the door? So they want to know how many students bought in advance and how many bought at the door. Okay, so that's going to give me my two variables. So advance, I'm going to call that capital A, because why not, is tickets sold in advance. And I'm going to call the ones at the door capital D, is tickets sold at the door. Okay, so I'm trying to figure out how many were sold at each location. Now, unfortunately, it's not broken down into two nice sentences or anything for us, so we need to look at what they tell us. And what they tell us is the totals. That's the part that we're going to use to make our equations. The ticket sales totaled 1,905. So how do you find total number of tickets? Well, you take the price of the ticket times how many you sold. So at the door or at advance is $6 times A. But I don't know how many A is, that's why it's a variable, plus, and then at the door, it's $7.50. D, because that's tickets sold at the door, and that totals $1,905. Then I have the total number of students that attended is 290. Well, how do you find total number of students attended? Well, you just take the total of tickets sold in advance, plus the number of tickets sold at the door, and that equals 290. So these are both in standard form, so what we want to do is go ahead and use elimination. I'm going to put numbers in front of my A and my D, and now what we do is we pick which one we want to eliminate. I want to eliminate A because the numbers in front of A are nice, 6 and 1. And remember, you take them and you do the opposite one. So the bottom equation, there's a 1 in front of it, so I'm going to multiply the top equation by 1. 6A times 1 is 6A, plus 750D times 1 is 750D, equals, and then 1,905 times 1 is 1,905. Then I have to take the 6 from the top equation and multiply that to the second equation. 1A times 6 is 6A, plus 1D times 6 is 6D, equals, and I'm kind of spreading them out so they line up, and then 290 times 6 is 1740, and again, I used a calculator earlier. Okay, so now I need to determine, should I add or should I subtract? So notice that the numbers in front of my A are the same. They're the number 6. So that's what I'm going to be eliminating. Should I do 6 plus 6 or 6 minus 6? Well, I should do minus. 6 minus 6 is 0A. And then I have to subtract everything else. 750 minus positive 6 is 150D. And then subtract, and you get 165. So that means my A's are gone. I just have 150D equals 165. Well, that's just a one-step equation. Even though it has a decimal, it's still the same process. So D equals, and if you did that on a calculator, you would get 110. Well, how do you find that solution? You take that and plug it into one of these. I'm going to plug it into the second one. So I just have A plus 110 equals 290. Well, I'm going to subtract 110 from both sides, and that gives me A equals 180. And there you go. Those are your answers. You just say that 110 tickets were sold at the door and 180 in advance. And there you go, you've answered your question.